Hey guys, so welcome back to my channel. We are going to discuss question number 2. Okay, so question number 2. Sorry. Alright, so question number 2. Give the alkenes formed when a forming alcohol is dehydrated. So this is the keyword, dehydrated with TSOH. Label a major product. So the major product is predicted by using the Zaitsev rule or Saytzeff rule when a mixture results. So there are two things that the question wanted from you. So the first one is you must provide the alkenes, and then when the alcohol is reacting or reacts with TSOH, and then the second thing you must label which one is the major product. So we look at the question A first. Okay, so for the question A, firstly what you're gonna do is that you are going to determine the beta carbon. So alpha carbon, in simply words we can say that the ones that attach to the OH, and then the beta carbons is the carbon that bonded to alpha carbons. So we got three different beta carbons in question A. This is the first beta carbon, and then this is the second beta carbon, and then this is the third beta carbon. So in all we can say that if we have three different beta carbons, therefore we're gonna have three different products. Means that we have the products will have three different alkenes. The substitution of alkenes also different, whether it is mono substituted, disubstituted, trisubstituted, or tetrasubstituted alkene. Okay, so okay, the question already mentioned that's dehydrated. So what means by dehydrated is that means that this mechanism, the type of mechanism is the dehydration of alcohol. Dehydration means that you remove one OH and one hydrogen, one protons from alcohol compounds as water, H2O. Remove as water molecules, which becomes as the byproduct or side product. Okay. While on the other hand, dehydration of alkene, you will get back the alcohol. Hydration means that the addition of water which you add one OH and one hydrogen atom. So it is vice versa to the dehydration. And then what is TSOH? TSOH is a para toluene sulfonic acid. It is a type of acid catalyst. Also a strong acid. So this is the reagents for the dehydration of alcohols. You can also use H2SO4, which is sulfuric acid, the other reagents. Okay, then we proceed. So the type or the class or the type of alcohol, you look at this OH. the alpha carbon, we got 3 beta carbon. If we got 3 beta carbons, then we will have a tertiary alcohol. If we got only 2 beta carbon, then it is secondary alcohol. If it has both same beta carbon, means that it only has 1 beta carbon, so it is primary alcohol. Okay, so these 3 structures are roughly the kind of the drafts I made before I present this question to you. Okay, these are not the final answer yet. The answer will become, okay, we'll look at the carbon beta one first. Okay, so we will remove one OH from this side, from alpha and beta. Okay, from this bonding C carbon bond. So we will remove this OH and then one hydrogen from this beta carbon. We expand the structure, so we remove this as water. Then we'll form a pi bond, a new pi bond here. Okay, so this is the first product. And then for the second products, we'll look at the second beta 2 carbon. We will remove this OH and one hydrogen at the beta 2 carbon. So we just remove, and then the double bond forms here inside the ring. And then for the third product, we'll look at the beta 3 carbon, the third beta carbon. We will expand, or we show the bonds between carbon and hydrogen. We expand the structure of hydrogen, and then we remove this hydrogen and one OH as water molecules. We will come out as water subproducts for dehydration of alcohols, and then we just remove them, the double bonds we form here. Okay, then we already answered the first question, which is we already provide or give the alkenes form. Next we gonna label which one is the major product. So we need to determine the substitution of the alkane formed. Firstly, look at this carbon double bond. We have I will use green color. One alkyl group, 2 alkyl group, and then 3 alkyl group. This is considered as also as alkyl group because this is a methyl, the simplest alkyl group, CH3. So the first product is a tri-substituted alkene, while for the second alkene I will use purple color. Okay, so this is carbon. We highlight the carbon double bond. This is carbon double bond, and then we look how many alkyl groups is bonded to the C double bond C, carbon double bond. which is the functional group of alkene. I will draw this. This is one alkyl group, ethyl, another alkyl groups, another alkyl groups, and another alkyl group. So this is the second products got 4 alkyl group. 4R means that it is a tetra substituted the alkene. And then for the last product, the third product, we will highlight the carbon double bond, and then I use different color. I will use this blue color. We will look at the carbon double bond. We have 1 alkyl group, 2 alkyl group, and 3 alkyl group. This is also a trisubstituted alkene. So we can conclude that the second product is the major product because it is bonded to 4 alkyl group. So just label as major product. So we already answered the second question, which is the question told to us, ask us to label major product, and then done. Next we will look at question B. Question B. Okay, first thing first, we're gonna determine or identify the alpha and also the beta carbon. I'll highlight the alpha carbon as the blue highlighter. The ones that attach bonded to OH, this is alpha carbon. And then the beta carbon is the carbon bonded to alpha carbon. I will highlight it by using yellow highlighter. This is a 1 beta carbon, CH2, CH2, CH3, CH2, CH2, CH3. And then this is another beta carbon, CH, CH3, CH3, CH3. Sorry, this is only C carbon because the bonds already for 1, 2, 3, 4. So I consider this is as the beta 1, and then this is the beta 2. So a class of alcohol is that for the question B is that secondary alcohol, because the neighboring carbon, the adjacent carbon bonded to alpha carbon is only 2, 1 here and 1 here. So it is secondary. The class of alcohol is secondary alcohol. And then we're gonna react it with TSOH, paratoluene sulfonic acid, or you can also use H2SO4. H2SO4. The products formed are 2 products only because it only has 2 beta carbons. Okay, give me some time to copy everything. Okay, consider this as the first carbon, first beta carbon, and then this is second beta carbon. Okay, we will do the same thing as the previous question. Okay, we will remove 1 hydrogen atom from beta carbon and 1 OH from alpha carbon, and then the double bond we form here. Just remove OH, 1 H, and we are done. this is our first product, which is carbon bond, which is a disubstituted because it's composed of two alkyl groups attached to C, so disubstituted alkene. For the second product, or the last product, we show the okay, sorry, we cannot remove the hydrogen because from the second beta carbon because it doesn't have hydrogen, so we must do the rearrangement because this is a secondary alcohol, so we can rearrange to get a more stable carbocation to the which is a tertiary alcohol. So I will show you the rearrangement. Okay, 1 2 shift. Okay, 1 2 shift. So what we are going to shift, okay, consider this OH is already removed, means that the double bond we form, the double bond we form here, okay, which is secondary carbocation. Okay, put here to tertiary carbocation. Okay, copy. I'm gonna paste this and explain to you. Alright, we are going to do 1 2 alkyl shift, which is 1 2 methyl shift. We are going to shifting this CH3 group onto this opposite or adjacent carbon, which is our carbocation, and then what we'll get, the carbocations with transfer of form here, and then this is forming a new methyl carbon bond, CH3C. So we will get like this. Okay, it is tertiary carbocation. 1 carbon, 2 carbon, 3 carbon, 3 neighboring carbon, means that it is tertiary carbocation, which is more stable. Then only we can use this carbocation to react with to form the second product. I copy this structure and then paste here. Okay, so the last product or the second product is the rearranged products. Okay, wait, I'm gonna think, where is the OH? Okay, OH we will replace with our so I just remove this structure and replace with the new one, the rearranged one. To remove the OH, to remove the carbocation, we can substitute with OH. So this is OH. Oops, sorry. OH. And then we can do the same thing. This is alpha carbon, this is beta carbon, beta 2, and then expand the hydrogen, structure of hydrogen. We gonna remove this hydrogen and this hydrogen and hydroxy group OH as water, and then the double bond will form here at the middle. Okay. So this is the second product. Okay. So let's determine the substitution of this alkene, the second product. 1 methyl group, 2 CH2, CH2, CH3, propyl group, and then 3 methyl group, 4 another methyl group. So this is a tetra substituted alkene. The rearranged product is known as tetra substituted. Okay. So we're gonna determine which one is the major product. Okay. Based on Zaitsev's rule, Zaitsev rule state that the more substituted alkene is the major product. So we can conclude that our second product, which is this product, is the major product, while this is the minor product. So we are going to finish it by labeling this major product. And I think that's all for this video. If you have anything, don't hesitate to ask me. Thank you and see you in the next video. Bye.